For example number 2, they ask us to show that the function f of x, which equals x minus 1 over 3x squared, is continuous at x sub naught equals 4. Now, the reason the solution of the book is not good enough for this class. Okay, so it's not. They say that well, it's a rational function, and the denominator is not vanishing at x equals 0 or x equals 4, so it is continuous by the rational function rule. Yeah, okay, but that's not how someone in a calculus course shows that. Okay, so here's how we show. This is the definition of continuity. A function is continuous, and this is what you need to do. So I'm not so concerned with what's in the book. I'm concerned with you following what's on these videos, so you need to do it this way. A function is continuous provided the following information is true. If you're in any course from here on out at any university and they ask you to prove that a function is continuous, this is exactly how you do it. You show that the limits as x approaches x naught from the left of that function is equal to the limit as x approaches x naught from the right of that function, which is equal to the function at x naught. So here's what we have to do. We have to show that not only do the left and the right limits give you the same value, but also that the function value is equivalent. So let's go ahead and figure each of these out. So we'll call this one part 1, we'll call this one part 2, and we'll show that this is part 3. So let's go ahead and work through that. So the limit as x approaches x naught from the left of f of x is the limit as x approaches 4 from the left hand side of x minus 1 over 3x squared. Now this can be separated into top and bottom limits, and the reason we can do that is because the limit of the denominator is not 0. If it was, we can't do this. Now, this function we know is continuous. It's linear. So we can plug in 4. And this function down here is also continuous. We already know that this guy is continuous, so the limit of it is equal to this. Now we do the same thing for the other side. Again, we can split that up because the limit as x approaches 4 from the right hand side exists in the denominator. So we can go ahead, and write this like this. And we know this is continuous, and we know this is continuous, so their limits then, we're using the idea of continuity here on these two guys. Now if you want to, you can go through and prove that these are continuous as well. So this will give me 4 minus 1 over 3 times, it didn't have to be negative 4 there, I don't know why I plugged that in there, squared, so that's 3 over 3 times 16, which is 1 over 16. Lastly, we have to show that now we've shown that these two are equal to each other, but we also need to show that f at x naught is equal to these guys. And f of x naught is f at 4, which is 4 minus 1 over 3 times 4 squared, which is also 1 over 16. So they all match. Because they all match, that's the proof that it's continuous. Now let's go ahead and let's try in example 3. You're going to see that this is not the case.